Let's see derivation of lens formula. Everybody has seen this one. This formula is used for thin lenses, and we need to develop this format with the help of refraction at curved surfaces. We have already developed this thing. Mu2 upon V minus mu1 upon U equals to mu2 minus mu1 upon R. With the help of this refraction at curved surfaces, we aim to develop lens formula, which is basically refraction at curved surfaces twice. Look here. Let's take a convex lens. It can be any lens, but we'll develop this format for convex lens. That's your lens. This is the optical axis. This is optical center for first curved surface. Let's call it P. This is optical center for second curved surface, P dash. Now, when I say thin lens means P dash is approximately 0. That means any distance which you take from P is same as that from P dash. They are almost same points. P dash is approximately 0. Only if we have what? Thin lenses. Now, this is air, this is glass, and this is air. We can always change refractive indexes, you know. In this, we'll be using mu. What is mu? Mu is refractive index of glass with respect to air. Refractive index of glass with respect to air. We can always write this whole format in this form. Refractive index of lens with respect to surrounding medium. Refractive index of lens with respect to surrounding medium, which is mu L divided by mu n. We can always change mu with mu L upon mu n. For example, if they give us glass lens in water, then this mu will be refractive index of glass, lenses of glass with respect to surrounding medium, which is water, and that will be mu glass divided by mu water. We'll see these things when we handle some examples and all. Right now, let's draw the ray diagram. So, this is the object. An incident ray arrives at this point. First time refraction will take place at this curved surface. This is air to glass refraction. At this point, you will draw a normal. This normal is shown by N1. N1, normal at the first curved surface. This will be the center of curvature, C1. We have been given radius of left curved surface as R1. We have been given radius of right side curved surface as R2. And remember, when you use R1 and R2, they should be used with proper sign. We'll see that. Now, this is a normal. The light ray is moving from rarer medium into a denser medium. When it moves from rarer into a denser, then it will move or deflect towards the normal. Let's deflect this thing towards the normal. Upon deflection, it finally meets at this point. This is I1. Let's further discuss this I1 before we complete the ray diagram. If I ask you, what is the medium of I1 and what type of image is it, real or virtual? Then what mostly people say that this I1 is in air, which is wrong. This I1 is in glass because we are using refraction at a curved surface, a single curved surface. There is a medium on the left side, there is a medium on the right side. For air to glass refraction, on the right side only glass is present. If only glass is present, then this I1 is not in air. This I1 is present in glass. A very simple way to identify what is the medium of I1 is medium of this ray. What is the medium of this ray? This is the refracted ray. Refracted ray is giving you what image? This refracted ray is present in glass and therefore this I1 is also in glass. And if I ask you now what type of image is it, real or virtual, then what people say, this I1 is in glass but it appears in air and therefore it is virtual. But no, this image is in glass and it also appears in glass. It is very much real for this type of ray diagram. कैसे? यहाँ देखना. Let's draw the whole thing in this form. Let's break the whole part in two parts, air to glass and then glass to air. Since we are discussing air to glass, look here. This is air and this is glass. That's your optical axis. This is the object, incident ray, refracted ray. This point is I1. This and this, they're what? Same rays. If you call it, let's say, X-ray, then this X-ray is the same, this X-ray. Now, in this setup, if I ask you, what is the medium of I1? You will simply say glass. And if I ask you, it appears in which medium? You will say glass. There is no contradiction and therefore this image is very much real. It's a real image. So this I1 is in glass and is what? Real. Because it is simply what? Refraction from air into glass. Now, look at the second surface now. Let's have refraction at the second surface. This incident ray, when meets the second curved surface, this was refracted ray for air to glass, but now it has become what? Incident ray. This incident ray meets at this point, and therefore you will draw a normal at this point. When you draw a normal at this point, that's your normal. N2. And it passes from C2. That's your normal. Now, light ray is now moving from glass into air. Glass into air, that means from denser medium into rarer medium. If it moves from denser to rarer, it will deflect away from the normal. And as it deflects away from the normal, it finally meets somewhere here. This is your final image I. We are interested in finding position of this image, which is V. Position of the object, which is U. So, let's discuss this ray diagram first. This I1 is what? I1 is a real image. I1 is a real image for air to glass refraction. I1 is real image for air to glass refraction. Because this is what? It's a refracted ray. But now, this refracted ray is also what? An incident ray. And incident ray, its intersection gives you what? Object. So this I1, it also behaves, this I1 also behaves as an object. Let's call it O dash. Remember, O dash and I1, they are what? Same. But once I say O dash, it's clear that it is what? An object. This O dash is what? An object. What is the medium? Medium is same, glass. Medium is same, glass. How do you decide medium? You ask yourself, what is the medium of the ray? Medium of the ray is what? Glass. You have produced this ray forward and it meets here. This whole thing is in what? Glass. This is in glass, and therefore this object is also in glass. Same thing, I1 is in glass. This I1 now behaves as an object, intermediate object, and that intermediate object is also in glass. But now if I ask you, what type of object is it? Real or virtual? Real or virtual? Then this is the incident ray. This incident ray, it cannot move like this, because once it comes out, it has to follow this path. And therefore, you cannot represent it with solid lines. It should be represented by broken lines like this. Now, broken lines means that's the actual path, represented by blue color solid line. Light ray comes like this, it deflects this way, and ultimately it deflects this way. That's your object, that's your final image. So what is this O dash? What type of object is it? Virtual. How come this object is virtual? Look again over here. For the second refraction that takes place from glass to air, this ray, which we have called what? X. That's your X ray. That's your X ray. This X ray, this X ray, this X ray is present in glass. This X ray, you're saying, is giving you an object which is O dash. Why does it give you an object? Because now it is an incident ray. This incident ray, its intersection is at this point. This object is in which medium? In the medium of incident ray, glass. But now it appears in which medium? Air. And therefore there is a contradiction, and because of this contradiction, this is a virtual object. It is a virtual object. Virtual intermediate object. This much you should know about the ray optics. When you draw the ray diagram and all, these things should be clear. This is what? Air to glass refraction, and then second time glass to air refraction. Glass to air refraction. This I1 is image for air to glass refraction. But same I1 is an object for glass to air refraction. It is an object for glass to air refraction. Now do one thing. Just a second, look here. Let's complete the ray diagram first in the second part also. This is ray X, which is this, and then ultimately it refracts and meets at this point. This point is your final image, I. That's your P, and this is your P dash. P dash I. This ray and this ray. Now, if I ask you for this ray diagram, what is the medium of I? And you will simply ask you, what is the medium of this ray? This ray, after refraction from glass to air, is present in what? Air. If it is present in air, then this I is also present in air. And this is an air. If I ask you what type of image is it, real or virtual? Remember, for this particular ray diagram, I'm asking you what type of image is it, real or virtual. Then this refracted ray, it is in air, and its intersection also appears in air. There is no contradiction, and therefore this image is very much a real image. That's your image, which is in air and is a real image. Hopefully you understood this much ray diagram, and then first note down this much. Those who can use this formula for first air to glass refraction, and then use the same formula for glass to air refraction, and ultimately develop this 1 upon f equals to 1 upon v minus 1 upon u. Those who cannot, simply wait, note down this much, and then we'll continue. Note down this. Done. Let's use this format. Mu2 upon v minus mu1 upon u equals to mu2 minus mu1 upon r for first air to glass refraction. Air to glass refraction. Image, object. Remember like this. Image, object. Object, image. Object, image. If you are ever confused, you can write like this. Object, image. That means mu1 is mu A and mu2 is mu glass. Let's put these values in this equation. Mu2 is glass, which we have taken as mu, divided by V. What is V? V is PI1. Write down PI1 plus PI1. It is a distance. Distance is always positive. We are on the right side of the optical center and therefore plus sign. If this part is 8 centimeter, then you would put B as what? Plus 8. This is your plus 8. Minus mu1 air, refractive index of air with respect to air is 1 divided by U. We can keep the original U for the lens. For the lens, this OP is basically U mod wise. If for the lens, somebody has the object at this position and image is at this position, this is P, P dash. They both are same. You can take them as P or P dash, whatever you wish. This is O, this is I. From the center, which is same as this as well as this. This is P, this is P dash. When you write OP, this OP is minus of U. Or it's better if you write U as minus OP, although they both are same. But mostly people will be happy if I write U as minus of OP. For the lens, if I ask you what is U, if this distance of object is 10 centimeter, then OP is 10, it's distance. What is U? U is what? Minus 10 or minus of OP. Now, for the first surface, whatever is U, for the first surface, whatever is U is the same U for the entire lens. And therefore, instead of wasting time in taking different values for refraction at single surface or for a lens, we will prefer writing U only at your U. Mu2 minus mu1 divided by R. What is R? R is simply R1. There is no need to write PC1. If you wish, you can do that. Suppose this first surface, its radius PC1 is 15 centimeter. 15. And somebody using this formula will put R as what? Plus 15. Why plus 15? On the right side. Center of curvature is on the right side. This R1 is nothing but PC1. So this R is R1. Now again, look at this format. If you look at this figure, this part is 8, OP. If this is 8, this is also 8. Now, if this is 8, then right at this position, you will put minus of 8 because U is used with proper sign. If you put minus of 8, that is already minus of 8. And therefore we have used directly what? U. Similarly, if somebody says that radius of curvature of the first part is 15 centimeter, then you will use plus 15 here. What is plus 15? Plus 15 PC1. You will understand this part when we discuss second refraction. But as of now, we have got the first equation. This is your first equation which we developed for air to glass refraction. Now, let's see second equation for glass to air refraction. for glass to air refraction, glass to air refraction. Now, in this format, always remember image mu2 object. What is this? Mu1. What is this? Mu2. Always write like this and there will be no confusion. Object to image, glass to air. Object to image. So mu1 gives us what? Object. Mu2 gives us what? Image. Write down the refraction type, glass to air, followed by mu1 and mu2, and you will never be confused in using these formulas. Now, how do you use this formula? Mu2. That's your mu2, image. Image. What is mu2? Mu air. What is that? 1 divided by V. What is V? P dash I. For glass to air refraction, P dash I is the final image position. In this figure, if I ask you what is V for the lens, you will say it is P dash I with plus sign. If P dash I is 6 centimeter, then V is what? Plus 6 for the lens. For glass to air refraction, this is again what? 6. This is what? 6. Then it's better you use what? V. And therefore, we'll be using V minus mu1. Mu1 glass, that is mu, divided by U. Now, this U is different. This time we are discussing glass to air. Glass to air. Glass to air, that means what is the object? O dash. This O dash is same as I1. पता है अपने को, देख चुके हैं इस चीज को, डिस्कस कर चुके हैं. So what is P dash O dash? That's the object. P dash O dash, and therefore somebody would put P dash O dash here like this. And it should be what? It is on the right side of the optical center, and therefore it should be taken plus. Again, if P dash O dash is 12 centimeter, then for this refraction, your V is plus of 12 on the right hand side. Plus of 12. Ultimately, you got what? 1 minus mu. There is no confusion. 1 minus mu. Mu minus 1. Divided by radius, which is what? R2. Now, sometimes people take minus R2. No, R1 and R2, they are always taken with proper sign. What is proper sign? If I ask you what is R2, you will not say R2 is P dash C2. R2 is not. PC1, P dash C2, all these things are what? Distances. R1, R2, UV. These are taken with proper sign. So what is R2? Radius of curvature of this part, it opens to the left. If this is origin, then center of curvature lies on the left side, and therefore R2 is what? Negative. That means, suppose radius of this part is 20 centimeter. Radius of this part is 20. That's the mod 20. If I ask you what is R2, you will say minus of 20. Which means somebody using this formula for this surface will put in place of R minus of 20. So if somebody is putting R as minus 20, it's better you use what? R2 directly. Because R2 is automatically what? Negative. And in case you have a convex surface at this place also, then your sign convention will be taken care of by the proper R2 symbol. Now, Once we develop this second equation, this is your equation number 2, and now we can remove this original format. Now look at this equation number 1 and equation number 2. Pi1, this is P dash O dash, but you know that Pi1 is same as, what is P? P dash. What is I1? What is I1? I1 is what? O dash. I1 is what? O dash, and therefore I1 is what? O dash. Which means this and this, they are same. Simply go for equation number 1 plus equation number 2, and hopefully you can see the answer. What is the answer? When you add all this, mu upon P dash O dash and mu upon Pi1, they are cancelled. 1 upon V minus 1 upon U is coming what? Mu minus 1, take it common. What is inside? Mu minus 1, once you take it common, 1 upon R1. But this is not mu minus 1, this is 1 minus mu. Make it mu minus 1, take negative sign out. That negative sign is now present in front of R2 like this. 1 upon V minus 1 upon U is coming mu minus 1, 1 upon R1 minus 1 upon R2. This is called Lensmaker's formula. Lensmaker's formula. Now, but our familiar shape is what? 1 upon F equals to 1 upon V minus 1 upon U. Let's take it to that part. 1 upon F equals to 1 upon V minus 1 upon U. But before that, do one thing, put down everything, and then we'll ultimately take it to that final format. Put down everything. Now, look here. How do you define focus? For a lens, if rays coming from infinity, these are rays coming from infinity, rays coming from infinity, they are always parallel like this. After refraction, the point on the optical axis where they meet, this is the point on the optical axis. The point on the optical axis where they meet is called focus of the lens. If this is the focus, then you also can see that this focus is nothing but image. Because the intersection of refracted rays, finally emergent rays, that gives you your image, and intersection of incident rays, which takes place at infinity, will give you what? Object. Since object is at infinity, your U becomes what? Minus of infinity for these two or parallel rays. Intersection of emergent rays, that will give you what? Image. That means distance from P dash or P, whatever you take. This P dash I is nothing but V. This P dash I is also called what? Focal length of the lens. Focal length. small f. P dash f is distance, is always positive. Small f, just like u, v, r1 and r2, should be taken with proper sign. Suppose for the convex lens, you can see that this intersection takes place here, and therefore this distance is suppose is 10 centimeter, and this is 10. This is also 10. But if you have a concave lens, then this intersection will take place on the left hand side. If intersection takes place on the left hand side, in that situation, your P dash I will be still 10, but your F will be minus of 10. But you don't have to worry about this when you develop this whole format, because we are taking all these things with proper sign. For this straight diagram, P dash I is positive as well as your F. So, if this is your P dash I, which is V, which is F, then if you put all these values in this equation, you get what? 1 upon V. What is V? F. Minus 1 upon U. What is U? Minus of infinity. On the right hand side, you've got mu minus 1, 1 upon R1 minus 1 upon R2. 1 upon infinity is what? 0. That means 1 upon F is coming mu minus 1, 1 upon R1 minus 1 upon R2. That means now this whole right hand side can be simply replaced by what? 1 upon F. And this also gives you focal length of a thin lens in terms of refractive index of the lens with respect to surrounding, as well as in terms of radius of curvature of both sides. So once you put mu minus 1, 1 upon R1 minus 1 upon R2 as 1 upon F back in this equation, you get the familiar result, which is 1 upon V minus 1 upon U is what? 1 upon F. This is the important result. This is also the important result. We have developed everything for convex lens, but concept is valid for any type of lens. Any type of lens. You can just simply change R1 and R2 with proper sign, mu with proper sign. For example, if I say that we have a lens of refractive index mu L, and surrounding medium, its refractive index is mu M, and this mu is refractive index of lens with respect to surrounding medium, which is mu L divided by mu M. And your 1 upon F then should be remembered like this: mu of lens divided by mu of surrounding medium minus 1 upon R1 minus 1 upon R2. Put down this much. Let's see angular magnification. We can use first and second equation also as a first method for angular magnification. If you remember, for refraction at curved surfaces, the format was this: mu 2 upon V minus mu 1 upon U, mu 2 minus mu 1 upon R, and magnification formula was HI upon HO. What was the trick? This part, mu1 upon U, divided by this part, mu2 upon V. This was a magnification for refraction at a curved surface. In our cases, we are using refraction at curved surfaces twice, once from air to glass and then from glass to air, which is like for the first refraction, that is air to glass. For air to glass refraction, your magnification formula is HI, which will be HI1, intermediate image, upon HO, this part, 1 upon U, divided by this part, mu upon pi1, mu upon pi1. And then for glass to air refraction, your HI, final image, divided by object. This intermediate image is now object. HI1. HI1. If you are confused, you can remember it like this. H O dash. We had developed O dash as I1. So HI upon HO. This HI is the final image which forms an error, divided by HO. Image of this becomes object of this, equals to what? Equals to this. This side divided by this. Look at the negative sign. This side divided by this, which is mu upon P dash O dash. Mu upon P dash O dash divided by 1 upon V. So, if you need HI upon HO, angular magnification, HI, final image, your object, then you should simply multiply these two equations. And when you multiply these two equations, you can see that HI1 and HI1, they are cancelled. When you multiply these two, you get HI upon HO. When you multiply this, this is what? This is 1 upon mu into U. This pi1 jumps into the numerator and becomes pi1. This is what? Mu into V divided by P dash O dash. So pi1 and P dash O dash, you know they are same. pi1 and P dash O dash. P is P dash, I1 is O dash. And therefore when you multiply pi1 and this, they are cancelled. Mu and mu, they are cancelled. And ultimately you get V upon U, which is called magnification M. This M is called angular magnification and is given by V upon U. Everything should be taken with proper sign. HI, HO, V, U, everything you need to take with proper sign. Put down this first method and then we'll see the second method for angular magnification. Now look at the second method for angular magnification. This is the thin lens and that's your optical axis. That's the object. AB. We'll take a ray starting from A, running parallel to the optical axis, and you know that when it comes out, it's going to meet at focus. And once I say that it meets at focus, a few people they think that image of A is present at F. But you know that it's not correct. This ray, which is running along the optical axis, is coming from B. A ray coming from B meets with a ray coming from A. What happens at the intersection point? Nothing. Because ray optics says that both rays should start from A. And therefore, there is no point in saying that image of A forms at F. This is just one ray which is coming from A. Let's take the second ray. This is the second ray which passes from the optical center and moves straight like this. Moves straight like this. This ray and this, they both are coming from A, and therefore this is the position of image of A, which is A dash. And just underneath, right here on the optical axis, you will find image of B dash. For this ray diagram, it's an inverted real image. We'll discuss real image, virtual image later. But as of now, this is the object and this is your image. Now, first important thing is that this intersection first it took place at F, but this is not the image point. For image, you should get both rays from the same point. From this A, these are two incident rays. Intersection of incident rays gives you what object. Intersection of refracted rays, that gives you what image A dash. Second important thing is, if I ask you why this ray is running straight, it doesn't suffer any refraction, then people say that, sir, it is passing from the optical center, therefore. No, that's not the argument. If something passes from the optical center like this, then it will suffer no refraction. This ray, it does suffer refraction. What basically is happening is, look at the middle portion of the lens, this portion. And what type of lens we have? Thin lens. If you remember, for refraction, we have developed concept of lateral displacement. What was lateral displacement? The ray was coming like this. It suffers refraction and then comes out. If this medium and this medium, they are same, not necessarily here. If this medium and this medium, they are same, then incident ray and emergent ray, they both are what? Parallel. They both are parallel. You can make them parallel. This ray which comes out is running parallel to the incident ray. This part was your lateral displacement. And this lateral displacement, I hope you remember, was a function of thickness of the glass slab. Thickness of the glass slab. So, what type of lens do we have? Thin. If it's a thin lens, that means this thickness is what? 0. If this thickness is 0, then your lateral displacement, that will also be what? 0. So, refraction, it takes place. But since this thickness T is almost 0, we say that this ray, it suffers almost 0 lateral displacement, and therefore it appears as if it is moving straight without any refraction. But remember, it suffers refraction, just that lateral displacement is what? 0. Something like this. Middle portion, if I draw the middle portion, if you can see it, let's make it thin like this. Then your ray is coming, it suffers refraction and then comes out. If you make this portion thinner, you won't be able to see this type of deflection. It will appear as if it is running straight. Now, once you say that it runs straight, a purpose is solved. What is the purpose? This, if is angle theta, as there is no lateral displacement, this angle will also be what? Theta. This is theta, this is theta. Let's take this center point as P. You can take this as P, this as P dash, or you can take the center as what? P. It doesn't matter because it's a thin lens. Now, what is tan theta? Tan theta is what? AB upon BP. AB upon BP. What is AB? HO. What is BP? Minus of U. 8 centimeter. BP is 8, but what is U? Minus of 8. For this side, what is tan theta? For this side, tan theta is A dash B dash upon PB dash. Tan theta is perpendicular upon base. Now, what is A dash B dash? Height of the image. But what basically it is in terms of HI, you cannot write this thing as HI. It should be minus of HI. Why? If I say this is 5 millimeters, if this is 5 millimeters, then A dash B dash is 5 millimeter plus 5. But if I ask you what is HI, you will say minus 5. So once you say HI is minus 5, you know that it's an inverted image. But A dash B dash, they are all what? Distances minus of HI. Divided by PV dash, it's on the right hand side, and therefore it is what? V. So you got tan theta from this, you got tan theta from that. Group all these things, both these results, and you get what? You get tan theta equals to HO divided by minus of U, which is equal to minus of HI divided by V. Negative cancel, and you got your HI upon HO as V upon U. Same result. Note down this much.